So now that we have this OAuth 2.0 access token, I'm going to show you something cool we can do with it. So I'm going to switch to my browser here, and I'm going to open up an incognito window. Now, don't worry, this is still safe for work. And I'm just going to go to gmail.com. Now, you'll notice that in this browser window, I'm not signed in. Google has no idea who I am. But let's do something. I'm going to go to https://www.googleapis.com. Oh, here it is. games/v1/players/me. And well, at this point, I'm getting back something that looks like sort of an error. And I guess that's not very interesting. But let me show you something. I'm going to add in $access token equals. I'm going to go back to Xcode and I'm going to copy this access token. Go back here and paste it into the URL. And look at that. We get back information about me. We get back my ID, my name, the URL of my avatar image. Now we're getting this information directly from the Play Game service. And maybe this seems normal to you, or maybe you're saying, wait a minute, you're able to access the Play Game service by hitting up web pages in your browser? What kind of crazy magic is this? And that brings us to, a somewhat oversimplified and inaccurate in places, but good enough for most intents and purposes, guide to REST. And as an added bonus, this presentation kind of adds with a bit of a lie, and we'll get to that in a bit. But first, let's talk about what we mean when we say that the Play Game service is a RESTful service. This is a phrase we throw around a lot here at Google because we are kind of a web services company, and this is kind of second nature to us. But I realize that to many of you out there, you're game developers, you're focused on client-side issues like AI and physics engines and multiplying matrices and stuff like that. And, you're thinking server-side stuff. I don't got time for that. I'm too busy trying to figure out pathfinding or whatever. So we're going to go over what it means to be a RESTful service. And if it feels too basic for you, you feel like you have a basic understanding of this, feel free to skip to the next video. I won't be offended too much. But let's talk about what a REST service really is. I suppose at its very basic core, REST is simply a set of rules about client-server communication that very typically is paired with HTTP as its application protocol. In theory, these two things don't have to go together, but in practice, very often, if somebody's talking about a REST service, they're talking about a service that uses HTTP, which, is that application protocol that your browser uses, which is great for us because it means that just about any language that kind of wants some basic web browser-like functionality already has some really nice support for making HTTP calls, and by extension has great support for communicating with servers in a RESTful way. So the Play Game service typically uses 4 types of calls. Get and post should be pretty familiar to you if you've done anything on the internet. 2 other calls that we use a little less frequently are put and delete. And let's go over what each of these means. Get is generally used to query the service. It's used to get information about a particular thing or get a list of things. Post and put are both used to create a new object or to update an existing object on the server. This is used, say, if you want to add or modify data up on the Play Game service. And delete, as its name might suggest, is used for deleting things. In case you're saying to yourself, hey, post and put look kind of similar, what's the difference? The main difference is that put is an idempotent call. And what does that mean? Well, that means that if you make the same put call over and over again, the result on the server will always be the same. Let's say, for instance, that I had a call to add an item to a shopping cart. If every time I made that call, another item were added to that shopping cart, that would not be idempotent. I would go from 1 to 2 to 3 to 4 to 5 bottles of shampoo. And that would then be a post call. On the other hand, if making that call repeatedly still only put 1 bottle of shampoo in my shopping cart, then that would be a put call. Perhaps another way to think about it is post is typically telling the server, hey, here's this update, I'd like you to apply, go ahead and supply your own logic because maybe there's other side effects that this call is going to make. Whereas put is generally telling the server, hey, just copy and paste this data over what you've got. Try not to think about it too much. Another analogy I've heard that I kind of like is put is sort of like setting an instance variable directly. We're going to call some value equals 5, whereas post is kind of like calling the setter. Maybe all it's going to do is set that value, but maybe there's other stuff going on that we don't know about. Whichever analogy works for you, go with it. And again, this whole thing somewhat oversimplified. So it's time for a little pop quiz. Here's a bunch of calls we're going to make to the service. See if you can guess what types of calls these would be. So listing all achievements, well, that is simply querying the service and getting back some data, so that's a GET call. Getting information about a particular player, well, that's also a GET call. A giveaway might be the fact that we use the word GET right there on the left, so keep that in mind. Incrementing an achievement, that's a POST call. And if you think about it, that kind of makes sense. If we had an achievement to, say, earn 100 coins, and we made a call to increment that achievement by 5 coins, you would expect that every time we made that call, it would go from 5 coins to 10 coins to 15 to 20 and so on. Right? That call is not idempotent. It would be different every time we made that call. How about unlocking an achievement? Now, if you were to say put, you might be right, and our judges will give you credit for that. Because if you think about it, if you were to make that unlock achievement call multiple times, that achievement would still stay unlocked. Basically, nothing else on our service changes that, and so that would be an idempotent call. However, in Play Games case, this is actually a post. And I believe the reason is the team wanted to leave things open for future functionality. Imagine that we had an achievement that you could unlock multiple times. By keeping this as a post, we basically leave the door open to add that feature in the future, without breaking backwards compatibility. But maybe this is a good time to remind you that if you're ever wondering about these calls, don't try and guess. Don't figure it out yourself. We have API documentation that you can review, and you should always check that out. And updating cloud save data, in this case, it is a put, because generally speaking, the service doesn't know much about this cloud save data that we're giving it. All it does is it copies and pastes this blob of text that we're giving it on top of the save game slot. And if we ask to save the same set of data multiple times, that data doesn't change on the service. So let's go back and review that call we made at the beginning of this lesson. This was a plain old GET call to googleapis.com/game/v1/player/me. Technically this looks like we're accessing a web page, but really we're not. Instead of hitting a web server, we're hitting a REST server. It just so happens that our browser, which communicates via HTTP, knows exactly how to make a GET call to that service. And that service spits back data, in this case JSON, that our browser knows how to render and display in a human-readable way. And if it seems weird that we're kind of blurring the lines between accessing a REST service and hitting a web server, this is basically a good thing. One of the nice advantages of accessing a REST service over HTTP is that you can do things like ping the service directly in your browser or make a curl call. And you can analyze the data that way without having to write your own client that's just made to access, the Play Game service. So that's kind of cool. You'll also notice, by the way, that this call did not work until we added our access token. And remember, that is our valet key that does two things. One, it tells the service who this me string actually refers to. The service is able to say, oh, this key is associated with Todd Kerpelman's account. Therefore, we must be talking about him. Second, it tells the service that I have given the Guess My Number application permission to find out who I am and retrieve basic information about me, like my avatar image and my player ID. And remember that I did this all in an incognito window, so this access key was basically the only thing the service had to go on to know that the person who made this call was Todd Kerpelman. And this means you have to be pretty careful about these access tokens. If someone else were to see this video in the next 60 minutes, and they copied that access token, they could essentially hit the Play Game service pretending that they were me because they have my access token. That token is really the only thing that identifies who I am. There's a reason, it's called a bearer token, and that's because the powers of that key are associated with the owner or bearer of that token. And so you need to treat these things with the same kind of respect you would treat a password. That means, for starters, don't go displaying it in YouTube videos where anybody could copy and paste it. That would be a terrible idea. In practice, this means you would not add it as a URL argument the way I did. You would more typically send the access token as an HTTP header. And most importantly, any call you make where you use an access token should always be over SSL. In fact, if I go back to my browser and I were to replace this HTTPS with HTTP, I'll get back an error telling me, sorry, you have to make this call over SSL. There are a few other interesting characteristics of REST services. I suppose your definition of interesting may vary. The first is that calls are stateless, meaning the service doesn't remember who you are from one call to the next. In some ways, maybe this seems like a drawback because every time you make a call to the service, you need to send your access token. You need to resend any information that the service should know about the player. There's sort of no shortcuts to, hey, remember, it's me. Here's another call I'd like to make. The big advantage is that this makes calls, in particular GET calls, very cacheable. And typically speaking, a lot of calls you're making through the game service tend to be GET calls. So this helps speed up things quite a bit. I suppose somewhat related to that fact is the fact that GET calls will have no effect on your data. If your player were to view their achievements 50 times, there would be no effect on their achievements. These calls are considered safe. As mentioned, put calls are idempotent, as are delete calls. You can delete an object multiple times and, calling delete a second or third time won't undelete the object. It'll just stay deleted. Typically, what you get back is human-readable JSON or XML. I don't know if this is a hard and fast rule. This is sort of by convention. And again, this makes debugging really nice and easy. You can see exactly what you're getting back from the service without having to, interpret it or run it through any other tools or anything like that. And perhaps more importantly, libraries exist for managing all of this stuff, and you should use them. We'll talk a little more about these libraries and the types you'll be encountering in the next lesson, so stay tuned.